Well, we are going to get into things today. Thank you for being here.
Yeah.
I'm James Ward.
I'm Josh Long.
And we are going to get hands-on. But before we get into the hands-on part, which will take most of the day, we did want to just get you familiar with the technologies that we're going to be diving into and start with that. So here's our agenda for the day.
Is that the only screen they've got the entire day?
You got to sit close.
Yeah,
I mean, luckily we're not showing a whole lot on the screen. So.
Well, we've got to, but yeah, okay.
So move if you need to, if you can't see the screen, because yeah, we are gonna show some stuff.
We can move this maybe. It's got wheels.
Just wheel it around.
Yeah,
like constantly roving.
Just constantly, yeah.
Yeah.
Have somebody moving the screen around. So, did you catch this? Yeah.
Okay, so here's our agenda for today. We are going to start with a little intro to Spring Boot. Who here has used Spring?
Oh,
okay.
Well, that's
A few people have used Spring. I'm sorry about your laptop. And so we'll start with that intro to Spring Boot, just to make sure everyone kind of knows what Spring Boot is, dependency injection, all the parts of how that works. And then we'll give you a little intro to Spring AI. And that will go, I don't know, maybe an hour and a half or so.
Yeah.
That'll be your best opportunity to ask questions about the technology that we'll be diving into.
Foundational stuff too, especially.
Yeah. And then we'll dive into the hands-on part of the workshop. For that part, you will need a laptop. It will need to be connected to the internet. You'll need a browser and access to your email account. And we have AWS accounts that we'll be using for the workshop. We've got the VS Code all set up in those. And so everything you need is going to be available in that AWS account. But you will need a laptop, access to your email to be able to log into it. And I don't know what the power situation is, but share chargers, do whatever you need to make sure your laptop stays powered on.
Close Slack.
Yeah.
Pro tip.
Pro tip.
Yeah.
So we'll do the Spring AI part of the workshop, and then we'll do the Embable part of the workshop.
Agentic.
Yeah.
I'm seriously. Who can see? Who's having trouble seeing this? Can anybody see this? In the back, can you see this?
So if you're in the back and you can't see it,
let us know, because we can
want
move
to at least temporarily move up. During the workshop, you won't need to really see the screen, but
yeah, I would have trouble seeing that. I'm having trouble seeing it from here. Gee.
Okay, so Josh is going to take over and give us our little intro to Spring.
Yeah.
Let's make sure that you are all working on the screen here.
It's all. Oh yeah. Here, you want to put it underneath that one?
Oh sure.
Another coaster.
Raise you up a little bit. Do you want HDMI or
yes.
just? Okay.
Let me make sure I have nothing. Yeah. Ooh. Yeah. Hello. Hello. It's not correct? Okay. System display. Thank you, sir.
Right.
Oh, that's a very light. That's
Yeah.
nice.
Nice and light.
Okay.
Who here has used Java? Okay, most people have some familiarity with Java. We are going to be using Java today. We could use Kotlin, but we figured Java would be a little more familiar to most people. So, that's what we're going to be using for programming language side. Maybe I'll give our little spiel on AI Java.
Please.
Probably if you've been watching what's going on in the AI ecosystem, you see a lot of Python. And Python, it's great language. But Josh and I work mostly in enterprise companies and with enterprise companies. And so their Java is pretty predominant. And so over the last 6 months, with Spring AI and Coog and Akka and Babel and LangChain4j, we've had a lot of the options in the JVM space really mature to the point where we don't necessarily have to use Python for AI anymore, which is good to have some options. So that's, I think we're pretty excited about what's happening in the AI space around Java. I think it's a great place to be. A lot of the enterprises have already built a lot of stuff on Java, and so being able to do the AI pieces also in Java, I think makes a lot of sense for those folks. And when we get into like in Babel, the paradigms that Embable is actually bringing to AI are pretty novel. They're not just a lot of the AI stuff in Python. maybe it isn't bringing some of the enterprise best practices that we've been using in Spring and other things for a while. So I think it's actually, and Babel is actually a leader in the space around how you build agentic orchestrated things. So we're going to dive into all that.
No, that's about right. I think, it's the right, we're in the right place at the right time. Okay, so I'm going to do a quick, just 101, just to make sure we're all on the same page. How many of you have got previous Spring experience? Some of you. Okay, good. So we'll do a quick primer. I just want to make sure you understand the fundamentals of what's happening here. Because by the time we get to in Babel, we're building on Spring AI, which is building on Spring Boot, which is building on Spring Framework, which is building on Java, which is building on decades and decades of suffering and pain, right? And lower levels of abstraction. So I want to make sure we're all kind of clear about the high flyer nature of what we're. So let's do a very quick intro. Spring and Spring Boot. So we're going to build a new application here. As always, we build new software by going to my second favorite place on the internet, start.spring.io. Here, you can see that. Oh, there we go. There it is. Start.spring.io, right? And so if you want to build a new application, start.spring.io. If you're restless and can't sleep, start.spring.io. If your children have indigestion, start.spring.io. And we're going to build a new application, and we have some choices we need to make when we build this application. What do we want to call this? I'm going to call it application because again, I'm amazing with names, right? And what version of Java do we want to use? Well, I'm going to be using Java 25. And look, Java 25 is the version that is out right now. I think the workshop's using 24? 21.
20.
Oh, don't say 20. Is it 20?
I think it's 21.
Oh, it's 21. Okay.
We're going to get it updated, but.
Well, anyway, you should be using 25, right?
Yes.
25 is the version today. And it has some of my favorite features, right? So if I can finally do this, I can create this script.java, and I can open this up. Let me make that font as big as humanly possible. So void main, and I can say, all right, hello, is it AI by the bay? Something, up. Okay, all right, up. Easy. There you go.
You're still getting used to those Vim
yeah,
findings.
Totally. So what I've got there is now if you look at that, it's a program I wrote in Java, so I'm going to run this, right, like so. And what that is it's a program written in Java, but notice I didn't compile it. I just interpreted it like a script. It actually gets compiled behind the scenes, but I'm using it like it's a script file, right? So what this is it's a script written in Java. Okay, it's a Java script. It's the very first good JavaScript. Now, this has been 30 years in the making, but we finally have it, okay? It's here. So that's a script. And look, pretty simple. The script has no class, like me, okay? No class at all. So it's a very, very simple language, very easy to understand, getting started with. Behind the scenes, that gets compiled and so on, but nonetheless. So we're going to use Java 25. I like Java 25. We're going to build a new application. I just want to make sure we have some very, very simple. We're not even doing the document stuff. Let's just talk about the absolute basics here. So we're going to build an application, and that's it. Let's just open this up, okay? Here we are. That was an alias, by the way. It's alias to unzip and open. And if you look at that, that is a shell script. It's a script written in Java. It's a JavaScript that just finds, it unzips a zip file and it finds the build file in that, and then it runs idea space and then pom.xml or build.gradle or build.gradle.kts. And I just want to be like 100% clear where we are. Spring is a framework that cares about how your objects are wired together. If you go the extra distance and tell it how things are wired together, it can do things for you on your behalf, right? I know this sounds ridiculous. It just sounds so simple, but it really is just that. It's objects get wired together. There's an opportunity between when you define the object and when somebody else consumes that object for the framework to do things on your behalf. And the way it does that is through polymorphism. It subclasses your types and introduces new concerns. So Spring has all these declarative concerns that you want to add to your applications. These concerns, if you were doing pure object orientation, would be weird to kind of add. You'd have to redundantly add them to every object you create, and you'd end up cluttering those objects with those concerns. So Spring can do that through, we call it aspect-oriented programming. But the idea is you create a type of object called foo. Somebody else expects a foo, but what they get is actually a dynamic subclass of foo that has all these extra capabilities woven in, okay? It's a magic trick. It's a sleight of hand. And if you understand that, then that's the foundation upon which everything else is built. So we have 3 pillars in Spring. There's dependence injection, which is one object depends on the other. You have aspect-oriented programming, which is one thing adds new capabilities to another in a generic single place. And then finally, you have portable service abstractions in Spring, which are the concept of abstractions that you can reuse to greatly reduce the amount of code you write for a given context, okay? That's it. Those are the 3 pillars of Spring. And they've been there since the day one. And if you hear people complaining about they don't understand Spring or there's like too much magic, whatever, just refer back to those 3 bullet points. That's the underpinning of everything we're trying to do here. It's just wiring your objects together and doing it in such a way that you can take advantage of declarative concerns. So what do I mean by that? Well,
Will you make your font as big as you
yeah,
possibly
how about that? Can you all see that in the back? Can you see that in San Francisco? Way
About
back?
3/4 of the way back. They can see.
Yeah, okay. Well, like this is, cool. There, how about that? I'm going to make it a little bit bigger, a little bit smaller. So there's several ways to tell Spring about how your objects are wired together. One is to be very explicit. So you can create a configuration class, right? I can call it my config. And let's say I have a customer service, right? And the customer service type here depends on something else. It has a dependency on another thing. Let's suppose I don't have on the class path here, do I, the JDBC types. So here we are, JDBC. Just add that there, and I'll add H2. Okay, keeping it nice and simple. Okay, so now I've got a application that has on a dependency on a data source, right? I need a private SQL data source to do my work, right? Here's that. Now this data source is a dependency. Now in good object-oriented programming, very simple object-oriented programming, you might have a class that wires these things up, right? So you can imagine I have a customer service object here, and that provides the definition of the customer service. What is that? Here we go. And I might have another method that returns a data source, which is a connection to a SQL database. And I can use the new embedded database builder. Here we go, like this. And then set type will be embedded database.h2. And then build, right? So I'm building a data source. And I've got these different wirings, these different associations. Now I can stipulate that this customer service needs another thing. I could just say that. That would actually work. Or in Spring, I could say, I have a collaborating object that is a dependency. I'm going to declare that as an argument. So now, in this case, there is no Spring. But you can see how by taking the time to factor out the definitions of these different objects, I'm already in a good place. I can already start to take advantage of Spring. And the way you do that with Spring is just say at configuration, and then annotate these with at bean. Now, you're telling Spring, hey, when you start up, look at these methods, invoke the methods, get the return value, keep them in a map, in effect, by its bean name, which is the method here, and the type, which is the return value, and then resolve any dependencies that are required. So in this case, it'll say, hey, customer service requires a data source. This happens to produce a data source. I'll take the output of this and plug it into that, right? Pretty simple so far. Same page, just basic dependency injection. You've probably seen this in Angular, and Angular is not a new thing at all, right? Okay, so that's just Java configuration. Now, of course, there's a couple problems with this. First of all, this customer service, this is the configuration I wrote for this type that I'm actually writing over here. So you might want to keep the configuration next to the logical code for the type. So in Spring, you can also discover things. We can actually discover your beans for you. We can use something called component scanning, right? This is redundant in this case. It's already on there. But if I go back to my config class, I can put component scan there, right? And what that'll tell Spring to do is to discover other objects that have at component on them, right? And it'll use convention there. So here I can say add component. There you go. Add this. And that'll discover this class. This is a marker. It's a tag. Spring will look for anything in the current package and below, and it'll find anything that has at component on it, and it'll say, oh, okay, this thing requires a data source. I happen to have a definition for data source over here. I shall resolve this by creating an instance of this and then plugging in the bean of the type data source. So in this case, I don't need that. It's redundant, right? So there's two different ways to describe to Spring how to create your objects. Explicitly, where you create a method and a return, and you have a bean that gets returned, or implicitly, where you tell Spring, just discover it for me and kind of create these objects for me by convention, okay? But ultimately, they all end up in the same giant big bag of beans, okay? They're all in the same map of bean IDs and types to instances of those objects. Fair enough so far? On the same page? Nothing special about this? This is not AI. This is 20-year-old technology we're talking about here. But
so real quick, one of the things that this gives us the ability to do is change our dependencies depending on the environment that we're running in. And so, like, why are we doing all this stuff to like create all these different kind of layers of beans and wiring them together with Spring? The biggest reason is that then we can change those beans depending on our environment. So the most common environment that you're going to switch between is your like production code and then your testing code. And so at test time, you could actually
Mock
inject
out.
in different things. You could mock things. You could use a different data source when you're running tests versus when you're running in production. So is that fair to
Yeah,
say?
100%.
Like testing is
That indirection is super key. And it's just object-oriented design. It's just polymorphism. I expect a thing of type foo. I get a foo. Who cares what subtype it is, as long as it meets that basic, walks like, talks like, quacks like a duck, right, contract. OK, so this is implicit. I'm using at component. But sometimes, these annotations, there's a bunch of other annotations that you can use in lieu of component. What you need to understand is that they all are meta-annotated. So at service does the same job as at component, except it actually has some extra benefits. And if you look at service itself, you look at the definition of it, it still is just an at component, right? So we say that this annotation itself is annotated with at component. So any meta annotation will also get picked up, right? And these meta annotations are there for, they have some technical implications. Like, for example, if I say at controller, right? If I say at controller tells Spring that this is meant to serve HTTP requests, or to serve GraphQL requests, or to serve RSocket requests, or to serve WebSocket requests. It depends on which layer you're working with. But it's a controller that adopts business logic to a protocol, usually over the network, right? And so this at controller is still just at component, right? It's a meta at controller. So it has it's at component at least, and then some extra capabilities, right? So when we say that these are annotations, they're called stereotype annotations, like UML. They denote the technical concern that this thing addresses in the logical sense of the code base. Okay?
And
so far,
that essentially just becomes like metadata around this object that then other things will then use to look up and find things of a particular stereotype.
Right. But you can like, if I wanted this to be a bean, all three of these annotations will have at component, and therefore this will be a bean. And in fact, at configuration, if you look at it, I know it's at component, right? Every type in Spring, every annotation in Spring that marks an object as being a bean for Spring to manage is ultimately annotated with at component. So you've got two different ways to go. One is at beans. The other is, the stereotype annotations. And you can mix and match. You can put the stereotype annotations on your own source code, and when you're defining instances of other people's objects that you don't have access to the source code for, do that here. Sorry?
Oh, he's taking a phone call.
Oh, OK. Yeah, well, good. So yeah, this is just wiring. OK, so far so good?
Yeah.
So, I just want to make sure we're on the same, because that's all we're doing, right? And the question then is that, at some point, I've got a database here. I've defined the bean of type data source. This is a thing that, however, is going to be common to all my applications. You're going to have a database. You're going to have a database. I'm going to have a database. And so at some point, we decided, well, those three things that we talked about, the three pillars of Spring Framework, right? One is portable service abstractions, right? Two is dependency injection. And three is aspect-oriented programming. So if you look at this, what is portable service abstractions in this case? Well, I'm using a database, but this is the regular Java JDBC data source. Have you ever written code using straight JDBC? It's a waking nightmare. It's an actual terrible abstraction. It's good for implementations of other frameworks or libraries, but it's not something that application developers are meant to use directly. It's a terrible way to run a railroad. So what we have is portable service abstractions. Let's say, for example, I wanted to simplify my use of JDBC. Instead of, should I implement a simple? Here, I'm going to do something that I would never do in polite company, just so you can see how we used to do it. Okay? So I'm going to take that type, and I'll implement a thing that returns all the customers in the database. Yeah? Get customers. OK, ready? Try var ps, try con equals this.datasource.get connection, right? Var ps equals con.prepare statement. Select all from customers. OK, and then throws exception, because of course there's exceptions. And then ps dot set int. There's no
parameters, but you're going to have to map the
where
results.
ID equals this. Now I've got ps dot set int is whatever, right? Get customer, whatever. I've got, you can see how that would work. And then I want to actually get the query, the result set. And now for each result, I'm going to go through that result set and then add it to this customers list. And I'll say, OK, customers dot add new customer rs dot get int ID rs dot get string name, yeah?
And this is the point where you're like, I wish I had an ORM.
Yeah, I wish, or just something to make this tedium go away, right? So now you get rid of that, get rid of this, and then, what is that? Oh, it's here. Return customer. Now, of course, this ignores also, what if I'm doing a mutation and I need to do a transaction? How do I do that consistently? Sorry? Oh, yeah, okay. What if I'm doing transactions? What if I'm doing exception handling? What if something goes wrong and I need to roll back the transaction? All that gets a lot more muddy. So instead of writing all this kind of code, we figured, okay, what's the actual business logic? We care about this bit where you're mapping, and we care about the query. Everything else is kind of just boilerplate. So we can use the Spring Framework JDBC client, for example. Okay, so JDBC client, here we go, and refactor that. There's this. And now we need a JDBC client. We'll define an instance of it over here. So bean JDBC client, pass in the data source. Okay, like that, and JDBC client dot create. Okay, so there's this. Now I'm going to rewrite this code now to take advantage of that new technology from the distant past. Return this dot. Okay, select all from customers.
So it's just a higher level abstraction over the JDBC connection prepared statement.
Right, exactly. So now I can just say new row mapper customer. There we are. Return this. This is an interface. Implement it. And then the thing I care about is this right here. That one little bit of code. Put that in there. Okay. Now, return a lambda. Good. 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 So there's the
better.
Much better, right? Like here, you can actually kind of see it. It's a, what is that? There you are. Nope, what happened? It's unhappy. So sad. Wait. Okay.
It's nice that your IDE is just telling you when you're doing things wrong.
Yeah. This. Okay. Okay. And then dot to list. There you go. So now I'm actually saying select all from customers. Here's the parameter. Here's the mapper of the results. Give it back to me as a list or as a single item or as a map or whatever, right? But I'm asking it for a list. So this is a lot cleaner than all this boilerplate code, and it's a lot less error prone as well. So that's a portable service abstraction, right? I'm using JDBC client to go a level above the JDBC, the raw JDBC data source, and I get that result. We talked about dependency injection. We talked about portable service abstractions. What if I wanted declarative transaction management? Well, I can now say, hey, wrap each method. I want each method to be transactional. So what I shall do is I'll decorate it with this annotation saying, hey, when somebody calls this method, start a transaction. If there are no exceptions thrown, then commit the transaction at the end of the method. Otherwise, roll it back. That's what this annotation is. That's AOP, aspect-oriented programming, right? So you understand these three things. You can see how we solve problems by moving progressively up the abstraction stack. But ultimately, it's just objects being injected and used and referenced from others. Now, at some point, we said, OK, well, this is boring. This is something that everybody's going to need if they're using JDBC. So in Spring Boot, what we've just looked at is Spring Framework. But in Spring Boot, we have this mechanism called auto configuration. And when Spring Boot starts up, it looks on the class path. It looks in the class path for this text file, meta-inf spring, and then this large text file, auto configuration.imports. Whatever. And it looks for this file, data source. These are text files. This text file contains class names, and it finds the classes, and it tries to run them when the program starts up. So this is just data source auto configuration. It has the configuration annotation on it, and it has other Java beans, like we saw earlier, right? And all of this code is concerned with detecting whether you have an embedded database, whether you have a connection pool on the class path, whether you've got a well-known standalone database instead of an embedded one, whether you've specified properties. But basically, this will get run when the program starts up, and it'll say, hey, it looks like you want a data source of some sort, and it looks like you've got an embedded database. So it'll actually automatically create this code for you, right? So the benefit is now it's doing things for you on your behalf. So that same program will still work even if I don't define any of this, actually. I don't have to define this or this class at all. That's called auto configuration. That's the thing that separates Spring Boot from Spring Framework, okay? Auto configuration is the next tranche. So we're in Spring Boot world here, and over here we're in.
So the first three were just Spring Framework.
Right.
Where you're manually configuring things. And then when we get to Spring Boot, that's where it weaves in the auto configuration just to make life super easy. You don't have to do all the boilerplate code to do all the creation of all the things that your application needs to, the services and those sorts of things underneath.
Right. And these definitions are, see this definition here? This says, hey, this is Spring saying, hey, I'm going to register this object of properties, JDBC connection details for you, but I'm only going to do it if nobody else has defined this type. This annotation is a guard. It's a conditional. It says, I'm going to do this thing based on the presence or lack of presence of this object. So if you define a bean of this type in your own code, then Spring won't bother registering this for you. So it'll back off. Whenever you want to override any cog in the machine, you can do that just by defining the bean and taking full control, right? So we provide the defaults, the convention, but you can provide the configuration and override these defaults at any stretch. It's not like Ruby on Rails where you get a lot of code-generated nonsense and you have to undo all of it if you want to make any changes to any of it, right? You can just replace one little part of it. So when you work with Spring AI, you're building on top of this. You're building on this auto configuration. You're building on top of dependency injection and portable service abstractions and aspect-oriented programming. But again, it's just about knowing to look for the auto configuration and knowing which objects to swap out to get the behavior you want, or which interfaces to implement to get the behavior you want. Any questions on this? This is not.
So one thing that often comes up is like,
Yeah.
okay, so with auto configuration, there's a lot of decisions being made for me, just a lot of defaults, which
Yep.
is helpful. But how would I as a developer know what those defaults are? Like, is the easiest way just turn on debug logs and see, when it starts up, like how things are getting wired together?
So Spring Boot has this thing called the actuator. This is the other thing, is Spring Boot is a framework. When we debuted Spring Boot back in 2013, Spring was already used in production, right? Like the largest companies in the world, when they grow up and want to be successful, they use Spring. So for example, Amazon, eBay, Tesla, Netflix, Alibaba, all of them have job listings for people using Spring. And infer from that what you will. But the point is, it's already in production. It's always been in production, right? I spoke. There's a small mom and pop company in China called Alibaba. Okay, now we just passed 11/11 a few days, like a week ago, right? Singles Day. In China, they have this sales holiday. It's kind of like our Black Friday or Cyber Monday or whatever. They have this sales holiday called 11/11. And in 2012, that one company made 3 times more than both Amazon and eBay combined had made the same year, right? In one day in China. And that's all powered by Spring. Every transaction, every service in that organization was Spring. So it's already very, very widely used in production, but we wanted to make it easier, right? This is 2012. Spring Boot came out in 2013, 2014. And one of the things we did was we added a lot. We have a lot of production-worthy focus, right? So we have the actuator, okay? I have this on the class path. I'm going to export all the details here. I'm going to show all the details through this config file. This is, by the way, the other way you can configure things in Spring Boot is by modifying this text file called application.properties. It's right here, right? And so I'm going to tell Spring Boot, hey, show everything. Don't do this in production, by the way. This is for the demo, not for production, okay? Because it's going to be wide open, okay? So I'm going to now start the program.
You can't put it behind security and export the metrics to your observability platform of choice.
Oops. I'm going to also add a web service so that the service doesn't just start up and then stop immediately. So I'll add this web. That's the other thing. We have this concept of starters in Spring Boot. You care about a concern like web programming or database programming. Here I've chosen web, right? When I add that web dependency, what I'm really getting is Spring Boot starter web. And a web is just a dependency that brings in the right code to start up that particular bit of support that you want. So I've added that to the class path. I've done nothing else, right? And now I've got an embedded web server started up on port 8080, right? There it is, and it's started up. So now if I go here, localhost 8080 actuator, you have all these different endpoints, actuator, here we go. And it shows you information about the objects in your program, right? And you can see, for example, which loggers are available and what their log levels are. You can post to this to change the log levels of a given logger so that you can get debug output while the program is still running, for example. You can see what objects have been created, which Spring objects are running in the program right now, and how they're wired together. So here's an object of type handler mapping, and it was defined in this class file, and has this dependency, and etc. So I can see my customer service. Here's my customer service object, and you can see that I created a customer service, but I asked for transaction management, so what I got was a subclass, right? I got a class that extends customer service dynamically, right? So the original.
The reason for that is that with the AOP, we're actually wrapping your customer service with something that adds the transaction capabilities onto it.
because object-oriented programming is nice, but it's not good for, like, how would you add transactions to something? You'd have to subclass it, right? Single responsibility principle. I have my business logic here, but now I want to do transaction management, so I create a subclass. Oh, what about logging? Okay, maybe I have another subclass. What about, auditing, whatever. I mean, all sorts of stuff, right? It gets very tedious. Object-oriented programming doesn't have a generic way to say, apply this behavior to everything, right? There's no way to say generically, here's transaction demarcation, add it to all things.
Someday we'll have it in Java with type classes.
Fingers crossed, right? But we don't have it right now. So Spring provides a way to do that through aspect-oriented programming, right? And anyway, here's all the objects that are in Spring. Okay, go back here. Here's your health endpoint, right? So you can see, this actually returns 200 if your service is up and running. It returns 500 if there's an exception or if some component is failing. So it says, hey, I've got a database. The validation, the connection query is good. Here's my file system. It's working so far. Here's my ping and my SSL certificates. They're all whatever. I have no SSL certificates configured, but if I did, they'd be shown here. So there's that. You've got info. This is a tabula rasa. This is for you to configure, right? It's empty. So you go over here, and you can put whatever identifying information you want here. So I can say, go back. Info dot, what do I do? Management info defaults enable env enabled is true. And I can say info dot message equals hi. Okay. Go here, and there's a message, right? Ooh. Now, where that's really useful is if you go to your build here, and I go up to the top, Spring Boot starter parent, go here, come on, git commit. Okay. I'm going to copy and paste this build plugin, go to my pom.xml, go all the way to the bottom here, add that in, get rid of the version because it's implied, and now I'm going to make this a Git repository, right? So now I say git init, git add, git commit -a m YOLO. Okay. Now, Maven skip test because I didn't write any tests. Package. Okay.
So you're showing how we can propagate, like, get information into your info that's exposed through Actuator.
So what that did is, exactly. So if I go over here to the target directory, you can see there's this new classes folder, and then there's a property file called git.properties that has information about the current build, right? Well, now I go over here, refresh, and it shows the information there. So imagine you make some changes to your code, go to CI, compile it, and then it gets deployed into production. Now you have this endpoint that says, hey, I'm running this version of the code, right? I can do git bisect. What about software bill of materials? You care about the provenance of your dependencies, right? So I can add a, Cyclone, right? Add that. Here's another plugin. Add this. Go to my build. Okay. So I'm adding that to the plugin here, and I go to my, do I have to do anything for that? I don't know, bomb. I don't know, let's just try it. We're going to go over here, skip tests, package, okay, reload. And now if we go back to here, Actuator, bomb, application, Cyclone, bill. Do I have to enable it? Bill of materials, Cyclone, bomb. SBOM. SBOM. Yeah, SBOM is unrestricted. So do I have SBOM in here?
No SBOM.
Oh, there it is.
Oh, there it was.
Actuator, SBOM. And it says there's an SBOM called application. Click on that, paste here. And here is the Cyclone SBOM showing you the provenance, the SHA of all the, because your application is, at the end of the day, a lot of mystery meat, right? You want to know who built it, where it came from, what the SHA of it all is, et cetera, and what the license is. Do I have the right to use it? All that kind of stuff is shown here. The Maven scopes, the vendor, the publisher of the dependency, the location of it, where it come from, the version, all that kind of stuff, right? Like is shown here. So what is all this to say? It's to say that this is a way to build production-worthy services. So much of the discussion around AI ignores that a lot of this stuff doesn't ever make it to production for a couple of reasons. First of all, you saw that we talked about that MIT thing a few weeks ago,
the
right?
MIT study that said 95% of AI projects have failed or something like that.
Yeah.
And I think it's because, getting into production is hard.
Yeah, but it's also that they're trying to rebuild all this. They've already got this institutional knowledge built up in these JVM and Spring-based applications, and now they're trying to rebuild new solutions on top of Python to support AI, when that means that they have to forego and abandon all this institutional knowledge that's built up over there, right? Why? Why not just build it up on top of the JVM? And on top of the JVM, since it's already such a mature platform, we've got these ability to secure and stabilize and observe and monitor and get provenance about your dependencies. All that's built in. Why would you forego all that just for this AI engineering? So what we're going to do today is we're going to see how easy it is to pull all that in. By the by, speaking of deployment, at some point you're going to deploy this to production, and you're going to care about a couple of things. So now let's go over here. CD, downloads application, right? I want to build, for example, I want to take my application. Let me just build a simple controller so we can see it worked. I'll go over here quickly. I'm going to build a simple HTTP controller at response body class hi controller. Okay, at get mapping. Okay, string. So I'm just creating a simple HTTP endpoint here. That's not quite what I meant.
Hello.
Okay, hi there. Good. Okay, we can actually just do that, I guess. So let's just see if that works locally first. Local host 8080. There we go. Okay, so we've got a simple HTTP endpoint. Now, I want to take this to production. There's a couple things you should know about. First of all, in the Java world, we have this thing called GraalVM. Skip tests, -p, native :compile. This will take a second.
So this is something that the JVM has added support for being able to take a JVM application and compile it into native code. So instead of running in the JVM, you can just make it native.
Like a C program or a Rust program or a Go program, whatever. It's just it is standalone, self-contained, statically linked, no JDK required, etc. And it's all transpiled into native code. Yes, sir?
No, yeah, good question.
Great question.
So it gets rid of all of the just-in-time compilation pieces. It actually does ahead-of-time compilation of the JVM program. So it takes a minute to actually create it because it's not just like packaging a JVM and running it on the JVM. It's actually turning it into a static native binary. And it does a lot of inspection of the execution paths in order to be able to do that, what would normally be just-in-time compilation of bytecode into actual ahead-of-time compiled bytecode.
So this is 48 milliseconds. You still need an operating system.
It has to run on an operating system. So I have some production applications that run via Docker, essentially, and just have I think it's called Docker from scratch. So you don't even need, like in the case of Docker, you don't even need to throw a whole operating system in the Docker container. And I just take the output from native image, put it into the container, and that's all that's in the container, and then can start that up. Yeah. Oh, sure. Yeah. So that question was about what do you actually need to run these native images? And you can target different operating systems. So if you're running in Docker, then you're going to target a Linux-based operating system. But Josh just built that on his Mac, and that all ran fine. So that's an ARM 64 instead of a AMD 64.
So it's 48 milliseconds to start the program now. So that's 20 times faster than it was on the JVM for the same program. And here's the same endpoint, right? Go back there. But
so it works just the same way that it did before.
Now it's not gonna there's a whole caveat. I'm sorry. There's an asterisk there. So there's some limitations that apply. Okay, we'll get into that if you have time later. But the point is, for 99% of the use cases, this is a really great deployment choice. And here's the process identifier. Go over here, PS-O RSS. Okay, that's the RAM. So measured in kilobytes. Divide by 1,000. That's 116 megs for web server with observability and our database. An embedded SQL database, by the way. Full SQL database running inside the JDK code, plus my program, right? So that's 116 megs of RAM versus, let's open up this pig dog. Here we go. JavaScript, by the way.
Is the Wi-Fi slow?
No.
No. Okay. Oh, just CNN.
Just CNN. Just loading. Here we go. What is that? 932 megs of RAM, right?
For CNN.com.
So my point is, the JVM is an amazing place to build and deploy and scale services today. It's unlike almost anything out there, and certainly a lot easier than everything else out there. So that's the foundation upon which we're building. Okay, it's a really nice place to be. Oh, by the way, you might want a Docker image. Oh yeah, I forgot about that. So spring boot :build -image. If you do that, it'll eventually spit out a Docker image for you. I ran the tests.
I think
So.
we're going to build Docker images in the workshop,
Yeah.
but I think we're using Jib, and I need to get that
That's fine.
switched over. But
Whatever. The point
there's
is,
different ways to create Docker
there's a built-in way.
images.
There's other ways that work as well. The point is, there's a lot of ways to get a Docker image out of this without having to write a line of anything in this case.
Docker files and
Yeah.
that.
So, okay, so that's Spring Boot and Spring Framework, just foundational, nothing to do with AI yet. I just want you to understand the shoulders on which we stand when we build today. Any questions on that? Any comments? Any feedback? I just want to make sure we're all clear about this because it's going to help later. So good.
Okay, ready to get into AI?
I think I am.
Let's do it.
All right.
Are you ready?
Let me just run the Docker image.
Oh, yeah.
Come
Let's-
this far.
Let's show them that it does actually work.
Minus P8080 colon 880. Is it?
Yep.
There you go. Okay, so there's that. I forgot to compile a native image into the Docker. I forgot to
Oh,
do
we
dash
could've-
P native,
yeah.
whatever. Okay,
So you could do either way, native or JVM for the container. But
Yeah.
it works.
good. That's shut down. So if I stop that,
Still
Is that
running
cached?
something somewhere. Yeah, question.
When we get to Jib, can you guys talk a little bit about how the XMX, how the memory management stuff?
The like JMX management. That's all exposed through Actuator.
yeah.
I think we will get into some of that in the workshop. So
Okay,
yeah,
perfect.
yeah. So the question for the camera was, how do we do all this with JMX? JMX is the built-in JVM kind of observability of how many threads you're using, how much memory you're using, all that kind of stuff. So, and then there are some pieces to JMX that also expose a kind of control plane into the JVM. And I think Spring uses some of that JMX, or
Yeah.
you at least can use
Yeah.
the actual management pieces of JMX.
Yes. Does anybody remember how to publish a port? Is it before?
Oh yeah, do it before. That was your problem, because it was being passed as a parameter to
the
container.
program. There you go. Okay.
Okay. Whew. So it works.
Painful. Yes, sir.
And actually, I love that topic, but my topic was more about memory management, filling the container, like XMX as a.
Oh, gotcha. Okay, sorry, I misunderstood that. Okay, so the question is, how do you set the memory parameters on the container, on the process within the container? And so for that one, fill the container. So on that one, we can answer that here because I don't think we go into that in the workshop. But for that, the build packs that Spring uses out of the box do a analysis on how much available memory is available to the container. And then it has a default of picking like 80% of that as your XMX. Sorry, I totally misunderstood your question. So so it will automatically select that for you when you use the build packs from Spring. You can override that, and there's many different knobs you can turn. One of the knobs is to tell the build pack when it creates the kind of information that then determines how much memory to use. You can say like, oh, I only want to use 50% of the available memory or something like that. And there's some different knobs that you can turn on the build pack kind of process that's doing that memory settings for you. The other option is you can just hard code a Java ops environment variable and override any of those parameters as well. So some different knobs to turn, but if you're using the Spring build packs, you're going to get good defaults out of the box.
Yeah.
This does use the available memory that comes to the Docker container. And so the JVM supports reading that information from C groups, which most platforms that run Docker containers will provide the available memory and available processors through C groups. The JVM sees that, and then you're able to use that information. And that all just gets managed for you. But there have been cases where C groups, and in the past, the information was not being propagated to the container correctly. And I think old versions of the JDK weren't able to read that C group information. So anyway, all that resulted in the JVM may think that it has like 1 billion gigs of memory available when really that's like the host platform's available memory. But if you're using all the modern stuff, it should just all be automatic.
Yeah, great question. Any other question? We're going to go into a quick 101 on Spring AI next, but I want to make sure we're all like copacetic here on the foundational Spring Boot 101 stuff. Because all that stuff is like.
we're going to be using like everything we just
Yeah,
showed today. So
At
you
some
gotta-
point or another in the life cycle,
Yeah.
Anybody? Any questions, comments, feedback?
Okay.
Okay.
Let's dive into AI.
Right. Now, Spring AI, we're going to talk about Spring AI. Spring AI is just one module. So we got Spring Boot upon which you can build almost anything. You've got batch processing. There's a project called Spring Batch. You've got messaging and integration called Spring Integration. You've got Spring for Kafka, Spring for RabbitMQ, Spring Security for OAuth and WebAuthn and one-time tokens and Kerberos and SAML and all that stuff, right? You've got this huge ecosystem. Spring AI is a module. It's a very rich, and that's why we're gathered here to talk about today is just about AI with Spring AI. But you could do full-day workshops on each of these projects, right? They're each in that domain, in that particular context. They're very, very rich. So one of the nice things about Spring AI is that it builds on Spring Boot, which in turn brings in all that other stuff if you want it, right? So your Spring AI applications aren't in a vacuum, right? You can use them to then pull in all these other interesting bits.
So you can use Spring AI with any of those
Security.
modules, with security, with whatever. And that's, I think, one of the great features with Spring, the Spring ecosystem, is that these things aren't created in isolation. Like at AWS, we have a good Python AI library called Strands. And Strands is great. It's a great library. But it exists on its own. It's not part of a broader ecosystem. It's like, oh, how do I combine GraphQL with Strands?
Oh, yeah, we have
Who
GraphQL
knows,
project.
right?
Yeah.
And so like in the case of Spring, we can kind of pick and choose which modules you want to bring together into what you're building.
That's a good point. We have Spring for GraphQL. We have Spring for gRPC. We have Spring, there's integrations for everything, right? Everything. So, okay. Whenever we talk about an application, I just did the most foundational hello world kind of stuff. So we just looked at objects and basics. That's a very contrived example, but it's more useful to have a domain that makes a lot of sense. So, and we struggled with this. We wanted to show you very quickly some of the AI stuff, and it's going to be a repeat. You're going to see this stuff again in a few minutes as you dive into it hands and feet first. But
our hands-on is Unicorn Store,
right? Okay.
Customer service agent. So we're that's what the hands-on will be.
Right. Well, then that's in the Silicon Valley, these unicorns are real.
Yeah,
they are. We have unicorn companies everywhere. But for most people outside the valley, there's ones that have something a little more grounded, something that can't fly. So we thought, in the Spring ecosystem, we have this Spring Pet Clinic. This is a sample application from the days of yore. The sample application was created back in like 2004 or whatever. Don't get me wrong, it's been updated of late, right? Here it is 5 days ago. And it's such a popular demo application that it's in turn inspired countless legion different implementations in terms of different technologies. So here's the Spring Pet Clinic in terms of our favorite language, Kotlin, and microservices, and REST, and AI, and JavaOQ, and JDBC, and Angular, and Vaadin, and Hilla, and React, and Istio, and HTMX, and Mustache, and GraphQL, and Reactive, and blah, blah, blah. Okay? So lots of different implementations. I thought we could look at that, but that's a little too much. We've only got 7 hours, not nearly enough time to look at all that. So we figured let's just find something in the same spirit as that, right? Something to do with like animals, dogs, and cats and stuff. Because I mean, who doesn't love animals, right? We love animals. We love dogs. We love cats. I love all. I love almost all animals. Okay, except my dog. It's not even true. I did love him. We didn't like him. You know what I'm saying? He was our dog. We loved him. But he wasn't a good boy. He was whatever the diametric opposite of good is, right? He was that. He was not good. But we kept him for 3 reasons. One is a very simple reason is that he's an animal and he deserves a loving home. Simple. Okay. That's part 1. Part 2 is ego. In my home, both my partner and my daughter speak 5 languages. So if we didn't have that stupid dog, I would be the stupidest in the house. That will not stand. Okay. It will not stand. So we keep him for that reason alone. And then finally, just being 100% honest with you all here, just being real with you all here, he is very, very, very cute, right? I mean, I know, so cute, so cute, but evil. Okay, pure malevolence, not a good boy. And we think about him. I think about him a lot. He reminds me of this other dog about which we learned during the pandemic named Prancer, and this dog went viral. So Prancer's owner was trying to find a new home for this dog, and she wrote this ad that went viral. She describes this dog thusly. She says, "Okay, I've tried. I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. And she continues on. She says, he was quiet and just laid on the couch, didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. Oh, this poor dog. What else? We already addressed the men and children situation. If you have people over, he'd have to be put away like he's a vacuum. I know finding someone who wants a Chucky doll in a dog's body is hard, but I have to try. And she signs off warning, oh, he's only 2 years old and will probably live to be 21 through pure spite. So take that into account if you're interested in. And by the way, who wouldn't be? Look at him, he's so cute. I know, super
Prancer.
cute. I would totally adopt that dog. Very, very cute. I might, I might lose a finger or whatever, but I'd totally pet that dog too. So I think about this dog a lot. And by the way, this dog did eventually get adopted because, like I said, it went viral. So here's People Magazine. Prancer, the demonic Chihuahua's new owner, says he helped her heal from past trauma. Hi. Here's USA Today. Demonic Chihuahua hellscape. Meet Prancer, the puppy everyone wants after a brutally honest Facebook review. Right. Here is BuzzFeed. We caught up with Prancer, the viral nightmare Chihuahua. And then, of course, here is Prancer in the New York Times, because slow news day or something, I don't know. So here's this, open, there's that. Prancer, the demonic Chihuahua, finds a home, right? So this dog went viral, eventually got adopted, but I like to think about this dog, and I like to think that we should build a service to support finding and adopting terrible, terrible dogs like Peanut and Prancer. So that's what we're gonna do here today, okay? So we're gonna go back to the console here.
Using AI.
The magic of AI, yeah.
The magic of AI.
Because, I mean, most people don't find their dogs like that, right? Most people, when they find a dog, they go to the shelter, and they talk to the shelter, and they interview the shelter about a potential dog, right? And that's how that works. So we're going to build the services to support that process. Hopefully, if you found your dog in the daily news, in the national news, that's probably an exception, not the rule, right? Most people aren't like Prancer. So we're going to build an application, as always. Going back to, where's my browser? Come on, browser, do the thing. Here, start that screen now. We're going to build an application here. We're going to call this Adoptions, again, because I'm great with names, amazing with names. Like I said, when I was a small boy, we had a small white dog, and my father named him White Dog. Again, great with names, okay? We're going to add
so Bedrock.
Yeah. Do you want to talk about this?
Oh, yeah, sure. So for today, we're going to be using an AWS service called Bedrock for the AI side of things. It's host models. There's like 200 plus models that we can use on there. We're going to be using 2 different models for this application, and you will be as well. The first one is going to be for embeddings, which allow us to take a string, essentially, turn it into a vectorized form, so that then we can do some similarity search on it. Oh, you're logging in.
Yeah, I got to log in.
AWS
I'm just
account.
like,
You don't want to show people your password
That's
to
okay.
AWS?
like, maybe I should.
So we'll use an embedding model from Bedrock, and then we're going to use a chat model from Bedrock as well to be able to give us the chat interface and be able to send text, get text back from the LLM. So 2 different models hosted on Bedrock, and we'll dive into some more details on that. But Josh has to get his 2-factor code to log into his AWS account.
I'm a professional.
So yeah, so while you're doing that, so Bedrock, it's going to be our LLM provider. We have support in Spring, which we're going to see for being able to do both the embeddings and the chat client. And then also in Spring AI, which we're not going to go into, is things like image generation. I think there's now audio generation in Spring AI, exposed in Spring AI. There's all sorts of different other pieces, multimodal support pieces in Spring AI. But for today, just embeddings and chat are going to be the things that we do.
Show them what.
Okay.
Oh, I did it.
Okay. So this is in the AWS console.
Can you see that in the back? We can make it bigger. Sorry, it's like.
So here's our model catalog. You'll see 249 different models that are available. Amazon has its own first-party models. We are going to be using, I think, for both of those, we're going to be using the Amazon models today. But you can pick whatever model you want to use. You can use the Anthropic Claude models. You can use the open, GPT OSS models are in here. You can use DeepSeek models. JetBrains even has models.
I don't
in
even
here,
know
so.
what's that one about. I don't know.
They're like for programming, like coding models. So Mistral models. So all sorts of different options that you can pick from. The Quen models, a lot of people really like the Quen models. So we've already configured Josh's laptop to be able to be authenticated to AWS. Just released, when was it, last Wednesday, Thursday? Was a new version of Spring AI 1.1. We're going to be using that today, the very new version. Things may break because the workshop was created on Spring 1.0. We're going to be using Spring 1.1.
Right.
And so we'll see how it goes. But I've done some testing. Hopefully things are good. But so Spring AI 1.1, it adds a new feature. Oh yeah, and you can watch Josh and I's live stream we did on Friday. It was like the unboxing of Spring AI 1.1. We did this last Friday. So
Code unboxing. Yeah, this is
so
Spring
we go
AI.
through kind of all the features. But one of the features that is now in Spring AI 1.1 is, go back to your AWS console real quick. You still have that open? Okay, there it is. Okay, so in the AWS console, it's now super easy with Spring 1.1 to be able to set up your local machine to talk to Bedrock. All you have to do is go into API keys, and then you can generate a short-term or long-term API key. You just get a single token, and you set that as an environment variable. It's like Bedrock, I don't know, bearer token or something like that. It even tells you in the console what to set that to. So that now works with Spring AI. So super easy. Sometimes it's kind of tricky to get your local machine off to AWS. If you're just using Bedrock, this has become a super easy way to do that. So we've already got Josh's machine all authenticated to AWS, and now we can build our dog adoption service.
Love it. Okay. Good stuff. Good stuff. Okay, so now, close that. Good. Here we are, over here. So we've got these. What is the difference between Bedrock and Converse, by the way? Did we talk about that?
Yeah, no, we didn't talk about that. So we're bringing in two different dependencies for the Spring application that we're going to build. And the first one is the Bedrock one. That's the one that we're going to use for embeddings. And then there's the Bedrock Converse one, which is used for chat. It could also be used for multimodal. And so that's why we're bringing in two different ones here for Bedrock. The Bedrock one and the Bedrock Converse one. And of course, Spring AI supports direct access to Claude models, to the Claude service, to OpenAI, I don't know.
20 different foundational models.
Many different vendors you can use in Spring AI. So for today, we're going to be using the Bedrock stuff.
Right, and by the way, there's also a Spring AI community where you can find, there's a lot of models that are supported in the Spring AI community there's a bunch of Chinese models, right? You can only run them within the geo zone, right? So it's very hard for us to test them because we don't have access to a data center there.
So those are provided through the Spring AI community.
Right, so you can find even more models there. It's just only so much we can manage at the same time. Okay, so we got both of these, and we're going to add now some other things. We need a observability, right? So go back to the actuator. We want to have web support, so we'll bring in the web support. We need some data access. So I'm going to bring in Spring Data JDBC, which is going to be like an ORM on top of the JDBC stuff, going a step further than what I showed you even earlier. We need a database, and obviously most of the time I reach for Postgres. But you know what else we need? We need a vector store. A vector store is a data store optimized for semantic similarity search, and there are many different vector stores out there. So you can take your pick. You can use Milvus, you can use Neo4j, Pinecone. There's a bunch that are purpose-built for just being vector stores, and then there are many that are just add-ons or extensions or plugins or whatever for existing data store infrastructure. So for example, here's Pinecone, and here's Milvus, and here's Weaviate, and Qdrint, and Chroma, and whatever. These are all purpose-built vector stores. But then there's also, you've got your Elasticsearch, your MongoDB, your, these are new entries. That's nice. Open search.
Nice.
Cool. We should figure out what that is.
Yeah.
I have no idea.
Integrate that.
Azure PG Vector, that's what we're going to use as PG Vector. You have Elastic, you have Apache Cassandra, you've got Redis, you've got Oracle, you've got MySQL, you've got Neo4j. So you've got a bunch of data stores that are, you've probably already got them deployed somewhere, is my point, right? And so we're going to use Postgres as a vector store. So we're going to get 2 for 1 here, okay? We're going to use PG Vector. That'll give us both a SQL database driver and the capability to act as a vector store. Now these are, at the moment, it's just a 2 for 1, but logically, we're getting 2 things. We're getting a vector store and a SQL data store, okay? They just happen to be the same thing at this time, but that's not always the case, and it doesn't need to be the case, okay? So far, so good. What version of Java?
Oh, do we need MCP?
Oh yeah, do you want to do that too?
Yeah.
I like that. Okay, MCP client, okay, hit enter. Okay.
So we just created that new project. It's just the stub with the dependencies, and now we'll start adding our functionality to this.
First things first, we need to, okay, let's try. You want to try using the new, do I need a key or anything like that?
Oh, let's not do that.
Okay, we'll just do the old-fashioned.
Old-fashioned.
Okay. Desktop reference, source, main, resources, application, properties. Is that it?
So there's a little bit of configuration that we need to set up with this new application. It's really just around like which database are we going to connect to. Josh already has Postgres with PG Vector running on his local machine, and so we need to point our application to that one. There is another way to do this, which we should use at some point, which is called test containers. Test containers is a nice feature that's supported in Spring that allows you to like automatically spin up the containers for given services. So we could have a test container for PG Vector and do this more automatically than we're doing it with the manual configuration. But I think the reason why we did the manual configuration is because we have our dogs for adoption in our database already kind of set and ready to go. So.
Yep.
Okay, so some configuration parameters here. First is which chat model do we want to use with Bedrock? We're going to use the Amazon Nova Lite model. Again, that could be Claude, that could be the GPT-OSS, DeepSeek, whatever. Forgot one dependency, which was we're going to do chat memory. So you pulled in the chat memory. That's also going to use the same database. Okay, we then have the embedding model, which is going to be Cohere. So that one's actually not using the Amazon one, which is called Titan or something. This one is the Cohere, which is a third-party model on Bedrock for doing our embeddings. We need to set the PG vector dimensions to 1024. Yeah, we'll talk about how those get used in a little bit. Anything else to point out in here? Some database connection information?
We'll come back to these two in a bit. This is a Java feature, and I want to talk about this. This is one of the, so this doesn't happen very often, so just let's just enjoy it. It's very rarely the case where we have something in Java that is not just as good, but better than the equivalent in other languages. But this is one of those very few cases. Now, if you've ever used one of these other programming languages, and by those other programming languages, I mean things like JavaScript, not the good kind, the bad kind, right? This is the good kind. This is the bad kind, right? So it's very important to know the distinction. If you've ever used JavaScript, if you know TypeScript, if you know Python, even Kotlin, sorry, it's got the suspend functions. It's the same failing, You've got C#, you've got whatever. A lot of these other languages, they have a thing called async await, right? And so the idea is, let's say I'm writing a JavaScript program, the bad kind, okay, not the good kind. So I want to get a customer here, and how do I get the customer? I describe it as a promise, and I say I'm going to return a customer here, and then I return window.fetch, blah, right? I call this URL and I get the response back, and it's a promise. And how do I consume that? Well, I can say const customer equals await get customer, right? And so what's happening behind the scenes is if I could somehow print out, the current thread or something like that, if I could do that, what you would see behind the scenes is that the thread here might be different than the thread over here, because behind the scenes, you've made a call to a network service that is going to block. It's going to take time waiting for those bytes to return, right? And that is you don't want to be stuck on this thread if all you're going to be doing is waiting for bytes to return, right? We call that blocking. And that frustrates your ability to scale, right? Because you've only got limited threads in your system, and it's very important not to sit there and not do anything if you're just waiting. You got to give that thread back and let somebody else use it.
In the case of Node, you have one thread.
Right, yeah, exactly. It's even worse in Node.
So do not block it.
Do not block it ever. So they have this mechanism where you tell the runtime, hey, I plan on blocking. I plan on doing something that would otherwise just sit here. Please feel free to take me off the main thread and let me resolve that in the background, and then let the main thread continue. So behind the scenes, the runtime will rewrite this code so that the thread that you're executing on here might actually be different over here, right? Because you're going to be doing this thing that might take a few seconds or milliseconds or whatever to resolve. You're making a network call, right? And, oops, come back. Well, I've lost it all. I don't know how I lost it. Whatever, the point is,
those VI bindings.
Yeah, I got to redo sequence. Oh, God. All right. I'm taking a spiritual journey, and I resolved this year I'm going to learn Vim motions. All right, I've been an Emacs person for decades, and this year I saw all the cool kids are using Vim, and I'm like, I'm gonna be cool. I'm gonna learn it. But Oh, it's not going well. It's been a year, and I'm not sure how well it's going. So anyway,
You still haven't figured out how to get out
I
of
still
it.
don't even know how to get out of Vim. It's been terrible, just terrible. So anyway, we've got this. Like the point is, this is low level, right? I have to write everything in terms of these asynchronous types, like promises, and I have to decorate my functions. I have to say that this is async, and I have to say I want to do await. Well, this is like low-level garbage management. Like if you're doing pointers in C++, this is the same thing for asynchronous composition. This is a waste of time, right? And
There's a great blog post about colored functions
Right.
and why they're bad. This is what we call function coloring, where we're having to delineate, these are the functions that do async things, and then these are the functions that don't. And
Right.
the problem with that is that it's really hard to mix and match.
Very.
You like oftentimes can't mix those. And so, so there's another approach that we can do in the world of the JVM, which is better, right?
Right, and it's more transparent. So this is the, if I wanted to make this call, I'd have to do it inside of another async function, right?
It propagates that.
It's-
Like anytime you want to call an async function, that thing then becomes an async function.
Right.
That's part of the challenge with
It
this,
spreads like a virus.
The function coloring.
Right. So we don't like this. So in Java, the interesting, what they did is they got rid of there's no keyword. You just call get customers. And as long as you are executing on a virtual thread, then it'll just automatically do the right thing, right? So I can demonstrate that here very quickly if you will permit me a brief digression here. Let's say I go here and I say at controller, at response body, class hi controller, right? Get mapping, map of string. Actually, I
So
wanna-
while you're writing that, I'll explain how this relates to AI, and you can keep coding.
Yeah.
So in the world of AI, obviously we're going to be making calls to LLMs, and so that those calls are going to be network calls up to our model. We're going to be sitting there waiting for the model to start returning text. Maybe we're streaming the text back, whatever. And while we're kind of waiting for that LLM to respond, we don't want to actually have threads being used in our application. That's just as wasteful. Whenever we're just waiting for something else to happen, don't have threads actually allocated to that. And so there's been many techniques like the async await in JavaScript with effect libraries, with futures and Scala, lots of different ways to get away from that just blocking threads for no good reason. And so now built into the JVM is something called virtual threads. And Spring supports this, so that all we have to do is turn on virtual threads, and automatically the JVM will know, okay, we're waiting on something to happen externally. Let's just take that virtual thread and not have it allocated to the actual operating system thread that's actually going to be executing that thing. So it's really just an efficiency that in the past we accomplished through being reactive. And of course, if you want to use reactive stuff, WebFlux in the Spring world, you can still do that in Spring. But a lot of that stuff isn't really needed anymore with virtual threads. We just get all the benefits that you want with not wasting resources just by setting that one parameter in the application
Right. There we go.
How's it going? You got your
Super duper good. I'm going to return. I'm creating a simple endpoint that's going to call another one. This endpoint returns after 5 seconds. It's a HTTP. This is equivalent to httpbin.org, right? And so I go to localhost. This is a Docker image that emulates HTTP bin. I go to localhost 80/delay/5, and it'll artificially take 5 seconds to return. Sort of like a simulated call to an LLM or something, where I'm waiting for bytes to return, and it just takes a long time, right? So I'm going to make a call now in this JVM program. I'm going to call that container. I'm going to make a note of the current thread before we make the call to the delayed service. I'll make a note of the thread afterwards, and then I'll just print out the current thread, right? So note, and then reload, okay? So let's see if that's happy. Okay, whoop. So I'm going to send 40 requests, 20 concurrently to localhost 80/80/, and did I call anything else? No, just that. Okay.
So it's just simulating, making a bunch of requests to this service that's calling that other blocking service, and then what's happening with our actual threads underneath the covers.
There you go. So you can see the logical thread is virtual thread number 98, virtual thread number 98. They're the same, but the actual operating system thread under the hood has changed. It went from fork join pool 1, worker 4, to fork join pool 1, worker 10, right? You can see there's the before and after has changed. Because I'm waiting for 5 seconds, it says, hey, you can't just be sitting here waiting. I'm going to park you in RAM, and I'll wait for the bytes to come back, and I'll put you back on another thread as soon as you're done. as soon as you're ready to go. So this happens automatically, right? It's a function of on what thread the framework is dispatching to this controller handler method, right? And we set that globally, pretty simple, like that, right? By setting Spring Threads virtual enabled. So if I get rid of that, then
So
the
you
world
just turned off the virtual threads.
I did, yeah.
Okay, making those requests again.
Okay.
And now,
Everything is the same, right? It's
same thread before and after.
1815, 1815, oh, well, 11.5, 11.5, 11.5, 16.5, 16.5, etc. So this is the old way. This is blocking. This is not going to scale well, right? So you just set that. You just do this, and you get the same thing as async await without having to worry about that. So it's actually a really nice feature.
That's cool.
What else do we want to show them here?
Okay.
We got the database. I guess that's it.
Let's get our dogs adopted.
Let's get them adopted. Okay, I'm going to connect to this database here. Hit test connection. Hit OK. Hit apply. Go over here. I've got this database tables. These tables. Let me just got maybe too much going on here. Let's just drop some.
What is all that stuff?
Oh, I'm working on another
Something
talk.
else you're working on.
Nice
That's for
thing.
tomorrow.
Yeah. Different day. Okay, so we've got our, we don't need this either, do we? Project actions, drop. Do we need the security stuff? No, we don't. Let's just get rid of that.
Clean up.
Yeah, I'll. Okay.
Okay, so we got our dogs.
We got one
in
table
a database.
called dog. And in this table, we've got a bunch of dogs that are up for adoption. And here's our buddy Prancer. His ID is 45. His name is Prancer. And is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, right? And surprising,
adopted.
surprising to everybody, no owner, right? So we need to fix that, right? So let's go back and first make sure I've restored the virtual threads. I did, good. Stop this. And we're going to do this by building a controller to support answering questions about the dogs in our fictitious dog adoption agency called Pooch Palace. So class adoptions controller. Is this, we're going to build a chat bot. Is this the only thing you can do with AI?
We could do all sorts of things. We've mentioned some of the multimodal stuff. This one is going to be a chat bot. We're going to be able to chat with the Pooch Palace and figure out which dog we want to adopt, which will be Prancer. But all sorts of things. Oh, and we'll show the structured data piece. Which is, So we'll get into some of the other things that we can do. But okay, so you're building right now just a basic controller. This is going to be allow us to make an HTTP request to this service and then interact with the LLM and start chatting. So the first thing we do is we add in our chat client. Our chat client comes in this is all stuff you've seen before with beans, the injection. So we're getting our chat client builder. This allows us to set some properties for when we actually set up our chat client. So right now we don't have any properties set up. We're just building that chat client. But what else did we have to show on there? Or you're just going ahead?
Yeah.
Okay, great. So we got our chat client. We got our HTTP request handler. This is allowing us to make a request. We're parameterizing it with a username, which we'll see why we're doing that for memory in a little bit.
We're just trying to establish a dial tone here. So hello, Josh. It's nice to meet you. If there's anything you'd like to talk about, or if you have any questions, feel free to let me ask. I like this, right? Very, very friendly. We were connected. Clearly, we're friends already. I'm sure it's
Wait,
fine.
real quick before you do that. Let me
yeah.
explain what just happened. We made an HTTP request to the Spring server. The Spring server then used the chat client to talk to Bedrock to make an LLM request. We got the response back from the LLM and then fed that back in the HTTP response. So is that everything?
Mm-hmm.
Okay.
And we printed it out to the console. And it's working, right? So okay, and this is the chat client here. We're injecting the builder. We're building a brand new instance of it. You can create as many chat clients as you want, right? But when you use the pre-configured injectable builder, it has a pointer to something called a chat model, okay? So chat models are stateful. They're heavy. So we have a Bedrock model, chat model implementation here. And you might have one or two models per application, but you might have dozens of chat clients. Chat clients are cheap. You can create them with different defaults, different security, different models, different chat models, different
Model
prompts.
parameters.
Yeah, so it's cheap
prompts.
and easy to create as many of these chat clients as you want, but they will point to the same model, which is auto-configured for you based on the properties and the environment and all that stuff. Okay, so far so good. So we have this application. We've established that we're working. It's got a dial tone. Let's just make sure everything's fine, right? Let's just see if it knows what's up. Oh, does not appear it does. So I'm sorry, but I don't have access to personal information about individuals unless it's been shared with me during our conversation. So clearly, it's got a memory problem, right? And that makes sense. These models are stateless. So what we want to do is give it access to a transcript of everything that's been said between us and the model. And we want to correlate that conversation with a particular user for tenancy, right, multi-tenancy. And one way to do that is to use something called an advisor. Advisors in Spring AI allow us to note and to intercept and to take note of and pre-process and post-process all requests and responses going to and from a model, right? So I can take the request, I can use an advisor to change that request or to add to it or whatever. I can then take the response and then use that to use an advisor to note that response and note the request as well. Advisors are like filters or interceptors or whatever. They have a chance to do anything with the request. So I'm going to use the prompt chat memory advisor, but we want to store it somewhere, right? Where do we store it? Well, probably a database, right? So I want to use a JDBC. JDBC, of course, is the Java database connectivity thing. And the question then, of course, is how much do we store, right? So if I point it to this data source, in theory, we could store everything, but I don't want to store everything, so we'll create a message window chat memory. That'll limit it to the last 20, I think.
It's the default is 20 windows, so it's a rolling window. So this is just a out-of-the-box advisor for Spring AI. So the advisors integrate with the chat client. We'll show you where they hook in a minute, but we can create our own advisors. There's, what other advisors are available?
Question answer, there's recursive, all sorts of good stuff. So now, try this again. Oh, it's going to want to store something in the database. Like I said, we already configured it to initialize a table to do that, right? So now we should actually have two tables. There. Spring AI chat memory at the moment is empty, right? And we created this advisor now. We've injected it and configured it on the chat client, but we also need to tell the AI model, the AI chat client with which user or against which user to correlate this transcript. So I'll say that the chat memory dot conversation ID is this. Okay, reload.
So when we send the question from you on this HTTP request up to the model, we're going to be able to essentially hook into that advisor and correlate the user's ID so that, if we have multiple users, are not going to get different memory.
Conversation ID is Josh, right? So it's correlated to that. You can imagine using Spring Security and injecting the principal, the current user authenticated principal, to get a different correlation ID, but I just hard-coded it in the path for the demo here.
Yeah, question.
Why did they create two rows?
The user question and the assistant response.
Yeah, so in the conversation, so the question for the camera was, why in that table did we see two different rows created when we made that one request? So what happens with the conversation with the LLM is we send the message to the LLM, that's the user message, and then we get the response back from the LLM. That becomes a second message that is labeled as assistant.
Right. And here's the, I asked it what's my name, and it remembered because it was able to, remember on each request, we're sending everything that's been sent prior to that request so that it can refresh itself on the conversation, right? It has context. Okay.
So this is just like the most simplest form of memory. There's other forms of memory. Maybe you want to do like automatic summarization. I think there's maybe even a built-in advisor for doing the like summary, keeping track of the summary and that sort of thing. So totally up to you, like how you want to use memory with your LLM. You likely, for anything real, need some kind of memory system because, again, the LLM has no memory between requests. We need to send all the context, all the information on every request to the LLM.
What was that thing we saw in Bedrock that just came out, the prompt
prompt
caching?
caching? Yeah, so Spring AI 1.1 just added support for prompt caching. Prompt caching is just giving you like a shortcut to a cache key on the actual LLM side of things. And so we'll have to figure out how to integrate that into our Pooch Palace.
But basically, the model, so we can do memory on the client, but also the models now are starting to debut this within the model themselves. So you can send a question and it'll do a fuzzy match and find similar, are you okay? Oh, laptop down. It'll find fuzzy responses and return like much faster. I think we saw it went from 10 seconds to 3 seconds for so many requests, whatever. For
like a whole book or something.
Yeah, like it was really, really big gains in certain cases. So that's actually pretty promising as well. And that also implies less token spend as well. We'll talk about what that means in a second, but it's a good deal. Okay, so it's worked. Here's my name is Josh. Okay, great, got a response. What's my name? It says, hello, Josh. It's remembered me by looking at the transcript that we gave it before, okay? So I think we're doing good, but we've got a big problem here, right? Which is that we've now got a wide open endpoint on the internet piped straight to my AWS account, right? And this isn't really helping. I mean, somebody could come along and use this to help get help with their homework or something, you know? Like, this isn't really helping people find the dog of their dreams, or in this case, nightmare. So what we want to do is to give this a focus, a mission, and we can do that by giving it a system prompt. So we shall configure a system prompt, and I happen to have a pre-written system prompt, right? Because I am a professional. So here's the system prompt. We're going to just cat that and put it in the clipboard buffer. And wait a minute, that's wrong. Much better, okay? Copy and paste that. Var system, paste that in.
So what is the system prompt that you've just given it?
It says, hello, come back. It says, you are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. Hi. Did I say Antwerp? I meant Oakland.
Yes.
It's not the same place. And London. Information about the dogs available will be presented below. If there's no information, then return a polite response suggesting we don't have any dogs available. Okay, great. So it's just, this is a system prompt. That's just a fancy word for the text that comes before our text, literally. When you think about all of AI engineering, at the end of the day, 99% of it boils down to just the almighty string concatenation operator, right? We're just concatenating strings in the right order, human language text. So when somebody says, well, you need to do Python for AI, they're delirious. I mean, there's just no reason. It's just text over REST API, right? I mean, 99% of the time, this is not particularly endemic to a particular language. So let's try this out now. Do you have any neurotic dogs? We don't have any dogs listed as neurotic. However, that was so fast, by the way. That was so fast. Sometimes I do this with one of those other models, and it's not like this. Variety of dogs with different temperaments and needs. If you're interested, I can provide more details about the dogs available at our different locations. Would you like to hear more about them? Sure thing. But the problem is it doesn't actually know how to resolve that request, right? It doesn't have access to the dogs.
So now it has the personality
right.
of that we want, knows what it's trying to do, what it's trying to help us with, but it doesn't have our dogs.
Nope. Let's see if it mentions Pooch Palace. Sometimes it'll even mention like Pooch Palace. So it'll clearly, I think it's caching it actually. I think the caching is kicking in. Let's see if we can delete all that.
Oh, it's pulling it from memory.
Wow, that's so fast. I cannot tell you how fast that is. That's crazy. Okay, anyway, it didn't work. It worked, but it doesn't mention Pooch Palace right now, but sometimes it does. The point is, it's acting like it should be able to help, but obviously it can't because it doesn't have access to the data. And so what we need to do is to give it access to that data through a pattern called RAG.
So RAG is retrieval augmented generation. Is that get that right?
Yeah.
RAG. So this is the way to get data into our prompt that's going to be sent to the LLM, so that now we can tell the LLM, like, here are the dogs that I have available. And we've got a large database of dogs. We don't want to send all the dogs on every single request that we make to the LLM. So in the RAG pattern, what we're going to do is we're going to be able to just pick a subset of the data to send into our prompt. So RAG is just a fancy way, pattern to be able to do that, like similarity search. So we're going to take the prompt that comes in, we're going to similarity search that with our data, and then we're going to inject automatically the data that matches into the prompt.
Right, so what I'm going to do is I'm going to go through this one time when the program starts up. I'm going to go through and I'll create a new Spring AI document, okay? Now this is going to contain data about the dogs like this, name, description, ID, etc. And it's just a string. There's no particular schema here. It's just so as long as we have the same text for all the records and it's consistent, then that's all that matters. And we're going to write it out to the vector store. Now, again, I'm dealing with in terms of the implementation. This is another portable served abstraction. The implementation of the vector store is for PG vector store, but the abstract type is called vector store. We'll just work in terms of that lower level type. I'm going to create a Spring AI document. Now, I've got a list of one here. It's a singleton list of one here that I'm passing to the vector store. Normally, if you have a large enough body of text, if you have like a Wikipedia page or an article or whatever, you'd tokenize it, right? You'd split it up into different chunks and then send that as individual documents, as a list of individual documents. And there's a whole hierarchy of splitters in Spring AI for exactly that kind of tokenization. But in this case, we just have a very simple little bit of text.
So in order to do the RAG, just to hop back for a second, we need to get our dogs that are in our adoption database vectorized. And that vectorized is just creating using a language model to create a matrix of numbers. And the reason why we're going to get to that matrix of numbers is because later we're going to send a prompt. We're going to then do a match to our database of dogs from that user prompt and try to find which dog is essentially matching the prompt that we've sent in. And so vectors, and this uses cosine similarity search or something underneath the covers, just becomes like a simple math equation to go from how similar are these two vectors.
We even have a simple vector store in memory implementation of the vector store interface that's in Spring AI. I wouldn't recommend you use it, but it's kind of illustrative and interesting. And you can see behind the scenes, most of the interesting logic is actually this cosine similarity and just basic high school math, matrix multiplication, that kind of stuff. So okay, we've got this application. I've got a document that has the data about the dogs, and we shall call it a document. Okay, and now, finally, I'm going to configure a question-answer advisor. This is another advisor that will, whenever we see a query, first go consult the vector store to find any relevant data that might match the query, right? So here we are. Come on. Question. Did I break something? Return, new, question. I'll just type it there, fine. It's like tripping. Okay, what?
Outside the package.
Oh, public.
Do you have a question and answer advisor somewhere else?
Is it a builder now? They have a builder? They built it?
Ah.
That's new. We've always, I've just returned the constructor. Okay, 1.1, like I said, there's some teething issues. 1.1 came out last week. Guess how much time we've had since last week? No time. Okay, so here we go. Question answer advisor, we'll just inject that just as we did the other prompt chat memory advisor. Okay, and configure that down here on the default advisors.
So we just added RAG to our chat client.
Easy.
Just through that question and answer advisor. So it has the vector store. We're storing the vectors in our PG vector database. And then that question and answer advisor is giving us the hook into our chat client to be able to do the RAG all for us.
And by the way, notice that it happened when the program started up because I wrote the code to do so in the constructor. And
the actual like vector, creating the vectors. So we did that just kind of manually. Usually you're going to have this as part of your like create and update processes when you're going to actually create your vectors. We didn't want to go that far. We're just manually creating the vectors here. Is that what you're pointing out?
Yeah.
And we only want to do that vectorization once. So,
once.
So now we're if false in that.
So
okay,
it took
there a question?
5.2 seconds here the first time. Let me restart it without the vector store capability, without the vectorization. Behind the scenes, by the way. And that's 1.5, so it's a lot better. And by the way, behind the scenes, it's using the embedding model, which points to Cohere, right? Like
the Cohere model on Bedrock. Yep.
Right.
Did you show them the table already for the?
Here's the table, and we'll get to your question in a second, my friend. Here's the table. Here's the ID, the content, the original content, the embedding that was created by the. So we sent the text, the plain text, to the embedding model. It sent us back this matrix of numbers. We then stored it in PG vector store, which is acting as our vector store. We stored it in the embedding column. So vector stores are data stores optimized for storing and querying these matrices, these vectors. Yes?
How does it know to ask the RAG first? Because you control the order?
So
it's
in an advisor, it's like an interceptor where it's going to intercept the incoming and then also allow you to intercept and manage the outgoing as well. So request response essentially. And a advisor, the question and answer advisor, is going to intercept the entry into that, do the RAG, do the cosine similarity search against our PG vector database, and then inject into the prompt that's going to go to the LLM. It's going to inject our dog data.
So,
yeah, another question.
What was the question, by the way?
Oh, the question was, how are we actually intercepting? Like, what is the actual way that question and answer advisor is hooking it into the chat client?
We got to go to that repetition of the question before we go.
Yes. Okay, do you have any neurotic dogs? Oh, it found Prancer.
Prancer is described as a demonic, neurotic dog that is man-hating, animal-hating, and children-hating, and looks like a gremlin. If you're interested in learning more about Prancer, and I am, or any other dogs we have available for adoption, please let me know. So that's worked. Now, this is text. Was there another question, by the way?
Oh, yes, another question.
Yeah.
You mentioned those are like simple vectorized embedded into strings.
Simple vector store?
Yeah. Is that able to, is that only like purely running on CPU or?
Yeah, this is not what you would use in any way.
So the simple vector store is just our storage, how we actually store those vectors. And the simple vector store is just an in-memory storage of our vectors. For this application, we're not using the simple vector store.
Thank
We
God.
will use it later
We will?
in the Embable workshop.
Oh, in the Babel one. Oh.
Yep. But for this one, we're using PG vector as that data store. So Spring has built into it the PG vector-based version of the vector store.
Right.
And so that's storing the vectors and then also giving us the search on those vectors as well, which in the case of PG vector is powered by Postgres. Okay.
We're wondering if somehow we want to use some, kind of like based on tools, and we have like sizable data, and we want to vectorize that.
Don't use this.
Is that usable, like this guy, is it useful or not?
No.
One important thing to point out is that the simple vector store isn't responsible for creating the vectors. So it doesn't do the actual tokenization of the string to the vector. We're using the Bedrock cohere model as a way to actually generate the vectors, and then we're using the vector store, in our case PG vector, to store the vectors.
Now I thought you mentioned there was a cosine, like building cosine in there.
It is, yeah, there is. So if you are storing your vectors in memory here with the simple vector store, then you can use the simple vector store's cosine similarity search. It's probably incredibly slow and depends on how many records you have. It'll get significantly slower. Whereas you should be using generally an external vector store that knows how to do cosine similarity search on the data side, not on the application
Using
side.
GPUs and things like that too,
Yeah.
usually. So this is, I just had deja vu, by the way. Like what's that? This total, I've been in this very moment. Have I spoken in this room before, I wonder?
Maybe years and years ago.
Yeah, anyway.
Okay.
Here's the PG vector store. That's the one we're using. I only mention the simple vector store to mention that it's like the searching for vectors and finding things related is not all that difficult. It's 300 lines of Java code. Not very efficient code, but it's still there, Okay, so do you understand that? So basically, we have a string. We took that string. We went to the embedding model. We said, hey, embedding model, embed this text, turn it into a float of numbers. The embedding model is an interface. The interface it points to, in this case, the Bedrock embedding models, right? Oh,
The cohere one.
this guy.
Oh, good work, buddy.
Hey. And then once it tokenizes it, then it then gets stored in the PG into the vector store implementation, which in this case again is Postgres. And so if you go here, here's the embedded form of the text, right? So far so good. I know it's a lot of moving parts, but all that to say, we tell Spring AI's chat client to consult that with this, and we got back a string. Now a string is no foundation upon which to build an abstraction. You're going to want strongly typed data at some point, right? We're type people. Is that fair?
Yeah.
Yeah.
I mean, we've been using strings in and strings out, but a lot of times when you're working with LLMs and you're building kind of hierarchies of pieces of your agent, you don't want to just take text in and out. You may want to actually pass data in and get data out. And so we're still going to pass text in this case, but at this point we can show, all right, let's say we wanted to not get text out, we wanted to get structured data. Let's now tell Spring AI to ask the LLM to get the data into a JSON form, and then we're going to deserialize that JSON form into the object, and all that is covered for us with just that dot entity instead of the dot content. So now we see, so we actually get it into an object from the LLM, and then we serialize, in this case, our HTTP body as a JSON object. So it's kind of like deserializing JSON from the LLM into an object, and then reserializing it into JSON coming out of the
Right.
HTTP controller.
But the point is, we do have a strongly typed object. If I assign this to a variable, it's a dog adoption suggestion, var, and then I can say entity dot name, description, and here's the integer ID, right? And so the model was smart enough to bundle up the data for us in a form we can use. I can get access to that integer, and I can use that to find the record. I don't have to parse this paragraph of text back. So that's called structured output mapping. Yes, sir?
Is that using the like model-specific
it's, I
So
think we
in-
have a generic one. It's getting better for certain models. Yeah.
Yeah, so we're using the Bedrock Converse library for the Bedrock models here, and Bedrock Converse has a structured output mode to it, and so this is just riding on top of that. Spring AI didn't have to do anything special there; it just used that. If you're not using Bedrock, you're using other models that may not have structured output support. I don't know what Spring AI would do if like as a fallback, if it's like okay, the model that I'm using doesn't actually have a way to do this. I'm not sure what Spring AI.
I'm not sure. I
does,
think
but
it'll.
we should experiment with that.
I don't want to be in that situation,
Yeah.
so I don't.
Yeah.
Okay. I'm going to go back to a string though, because for now, there's usually these things are multi-step, right? We just asked a question, we got a response back. That's called one-shot prompting, right? Sometimes though, more often than not, and we'll talk about this a lot more when we get to Babel, there's multiple steps, and we want to orchestrate that, or at least move that workflow along. The next step here is now that we found the dog of our dreams, right? Like go back over here, reload. Do you have any neurotic dogs? Yes, we found Prancer, but I'd like more information about Prancer. No, I don't want more information. I want to just adopt him. He sounds delightful, right? Sounds like the dog for me. So what I want to do is I want to build a service to schedule a pickup, an appointment to come pick up this dog, right? And then take him home and adopt him, So we're going to integrate here our dog adoption scheduler. Now this is where I think the real opportunity is, right? We've integrated the AI with our data using RAG, and now we're going to integrate the business logic. Yes, sir.
I have a question. So you said in the previous request it was intercepted before it went to the model, and you added embeddings.
Yep.
But here the second thing where you say I'm ready to adapt, and you shouldn't be intercepting the request because there's not a search on the top.
Yeah.
So how do you then make it skip and not go through embeddings?
Yeah, so we are, in this case, you're right, going to re-embed the data, and so that's unnecessary. What we don't really know is like when we actually get this request, do we want to provide data? Do we want to provide tools? When would we decide like when to provide one or the other of those? And so it actually gets tricky. So the easiest approach, which we're going to do here, is just re-embed the data, even though it's not necessary. But we don't know when we shouldn't embed the data. So I think it's one of the challenging pieces with AI is deciding like, what do you put into context when, and how do you make the decision on when to do that? Because it's all just dynamic free-form text. When we get into agent orchestration within Babel, you'll see where we get much more granular control about what actually goes into the context.
But could you not have replaced it with just a bunch of tools and not even throw it back up front? Say, ask me for a list of dogs, then I know exactly what to do.
A great question. So yes, so what we're going to be doing is using tools to actually do the dog scheduling. You can also use tools to provide data into the prompt. The challenge with that, and the reason why it's different from RAG, is that the LLM is going to decide when to call tools. And if it decides that it needs to go fetch data from a database, then it's going to result in a tool call, which will then go do the fetch. And so then we've got a few more kind of turns through the LLM to get to the same point, whereas RAG is like proactive from my side. No matter what, I'm going to put that data into the prompt with RAG. And so there, I think, are different times when you want to do RAG versus you want to do tools. Like, do you always want to have that data in? And maybe like you're saying in this case, maybe we don't always want to have that data in, and it should be a tool instead.
And you're optimizing, do I want to re-encode something, or do I want to make the LLM do work? And I'm not sure which one creates more carbon for the planet, but it'd be very hard to, Okay, so I've written this straw person dog adoption scheduler. It's a method that takes an integer for the ID and the name, and given that, it's going to give us a date when we can come and pick up the dog. I've just hard-coded the date for 3 days in the future, and I've printed out scheduling the dog ID / dog name for pickup at, and then I printed out the time. And we've annotated this. We've decorated this business logic with the @tool annotation, and we've been very clear about what the intent of this method, of this tool is. This is a tool in the toolbox, and this tool can do one thing and one thing only, which is to help schedule an appointment to pick up a dog for adoption at, I should have said, at a Pooch Palace location, right?
So this description is really important because the tool description gets sent to the LLM, and that's how the LLM then decides when to call that tool.
Yeah.
So the LLM really needs this information so that it can make a good decision on when to call tools. So this is the tool calling pattern with LLMs. Most LLMs now support the ability to provide into your context the list of tools that are available, the metadata about those tools, like the description, the potential input parameters that are required, and then even potentially the output schema that's going to come out of that tool call.
Yes. When you were young and your mom told you to use your words, this is what she was talking about, okay? She's saying clearly document your AI inputs, okay? This is very, very important. So I've got a dog adoption scheduler. I'm going to make the model aware of that tool by injecting it into the constructor here, just as I have so many other things, and then giving a pointer to it to the default tools method here, okay? So I've run that. Now let's go ahead and get rid of the cached data, okay? So now we say, do you have any neurotic dogs? Okay, good. Found our buddy Prancer. Fantastic. Fantastic. When can I pick
So on that run, it didn't
Prancer?
run your tool. It's
No.
the model's like, I don't need to. I know that I have this scheduling tool available, but I'm not going to call it this time.
No output here. When can I, from the Oakland location. Okay, and don't have is this got the scheduler, default tools.
Something changed with Spring AI 1.1.
Oh boy, that's fun.
Oh boy.
Scheduler, schedule.
Check your memory real quick. See.
But didn't I? Let's try again. We can always roll back. Do you have any neurotic dogs? Yes. Okay. Prancer. So,
When can we schedule it?
when can I pick up? What does the prompt say for the tool? Wait. Schedule an appointment to pick up or adopt a dog. Oh no, schedule to pick up.
We're live prompt engineering.
Dog from a Pooch Palace location. That looks okay. Okay.
Do you restart your? Oh, this is all in the same process.
Did it? So we're gonna do some.
Oh no.
I don't know. We don't know. Who knows? Was it 1 out of 3?
We're trying this.
Yeah, I'm not gonna.
We could just skip to MCP.
Well, I mean, who knows if that's gonna work? Oh my
Right.
God. Okay, so okay, here we go. Take 5.
Wait, does it have the memory?
Oh, let me see. Delete this. Goodbye to that. And now, do you have any neurotic dogs? Okay, good. It's Prancer. By the way, are we running on Spring AI 1. How do we know? Is that builder still working? How do I know which version I'm using? Maybe even just make sure it's reloaded, you know? Okay. And now, we go over here.
It doesn't know about our tools. Wait, are you doing the tool setup right?
Maybe not. I don't know. I've never used this technology before, clearly. Okay, hold on. We got the scheduler. Default tools. Scheduler. Dog adoption scheduler. Schedule. Int dog ID. String dog name.
That all looks right, huh?
Oh, wait. Okay. Color me confused. So, when can I pick up Prancer?
The request being sent to the LLM or being recorded in the ADD, and so could we not simply look at what's being sent to the other tools being offered?
Yeah, there is a way to do debugging to see what the tools are.
I am very confused about that, actually. Wait, has anything... I'm still not convinced.
That you're on
The right
old
version. 1 out of 3, that looks right. Got the AI advisors, web, data, JWC, actuator, vector store. Did I simply type something differently?
Do you have something like slash info or just slash just tell your MCP server or the
It's not MCP yet,
Yeah, we haven't gone to MCP yet, so that's part of what's.
making this more fun.
Yeah.
Dog adoption scheduler. Schedule, that looks right. Schedule an appointment. The ID of the dog, the name of the dog, 3 days in the future.
not MCP, but tool. You have
there is a way to turn on the actual like prompts to see the raw prompts. So we could do that. Hopefully we don't have to do that live.
Yeah.
But, let's should we skip to MCP?
Yeah, let's try that.
Let's try it. Let's
I'm
try it
so
because
confused.
maybe it's,
Schedule it.
yeah.
Okay, whatever. Let's just skip to MCP. So
Okay.
Normally-
So this is like local tool calling. So if something is weird, we'll figure it out. But with tool calling, your tool calls can be in the same process as your agent, essentially. We've got our agent, our dog adoption agent, and we can do the tool annotations right in the same process, and those will get called. And Spring will manage all that for us. And we'll figure out why it's not working in a minute. But we can also take those tools and make them remote tools. And MCP is the primary protocol to be able to essentially have a microservices architecture so that all of our tools aren't running in our same process as our agent, can be external. And we can have many MCP servers. We can use off-the-shelf MCP servers. We can build our own MCP servers. But MCP becomes the standard protocol to externalize those tools and call them over HTTP. You may be familiar with MCP from code assistants. AI code assistants often use now MCP as a way to integrate with all sorts of different things. There's like thousands of MCP servers. But we can also use it for like this enterprise integration scenario where we're exposing tools to our LLM and doing that with a network protocol, which is MCP.
you're not going to like what I just discovered.
Oh.
I rolled it back. I went to 103, and I deleted the target directory. It wasn't seeing the new class.
Oh.
So it wasn't like, it was just weird
Huh.
state. So I'm going to, it worked.
So
But I did that.
1.1 works.
No, 1.03 worked when I deleted the target
Oh,
directory.
okay. So
now,
1.1 should
let's
work.
see if that works. I don't know.
Okay.
Who knows? Could have just been a
Something
compiler.
got wonky somewhere.
Yeah. Okay. Fine.
Just clean and restart. That's,
Yeah,
if
reset.
things are not working as expected, just clear the cache, essentially.
Yeah. Got Prancer. Good.
Okay, found Prancer. When can we pick up Prancer? Yay!
November 17th. November 20th.
So
3 days. And here's the scheduling blah. So this is local tool calling. Haven't done the MCP stuff yet, right? This is the stuff we were just trying to make work unsuccessfully for a few minutes there. It now works magically with no changes whatsoever, except that I deleted my target directory. This is why I'm not like worried about AI taking our jobs. It doesn't even know when to run.
And the target directory is the cache for all the built sources. And you all know the joke that there are, there are two hard things in computer science: naming, caching, and off-by-oneers.
Exactly.
So two hard things: naming, caching, and off-by-oneers.
All
Okay.
right. So that's local.
Okay.
As you said,
local
though,
tool calling.
let's take advantage of remote tool calling. So via MCP. So I went over here, created a new service, Model Context Protocol and web. Is this here? No, I haven't opened it yet.
So we're going to take those tools that we're running in the same process as our agent, move them out to an MCP server, so that then we can have that remote architecture for our tools. So you're going to run it on a different port so we don't get port conflicts.
Yeah. And this is going to be new for me. Here we go. Paste that in there. Should I do the old thing or is it new?
No,
thing?
we don't need to.
Well, how do we do it?
No,
Should we
you
just
do
annotate?
it.
Just
You
annotate
just
MCP tool?
Yep.
Okay.
So what Josh has done is taken that tool code out of our agent, moved it into an MCP server project, and then just changing some annotations. I think we can actually use the same annotations with our local versus our MCP tools, but there's some additional functionality in MCP that gets exposed when we use the MCP-based annotations. So yeah, we've got our MCP tool. It's got a description, same thing as before, our MCP arguments. So then this is all brand new as of last
Week,
Wednesday. So,
basically.
yeah.
So that should do it. I don't know if it's worked. We can go back over here and then call it from the client, yeah?
Yeah, so now we need to tell our agent side to point to that MCP server. So we need to do some now configuration that says, all right, here's your MCP server that you're going to connect to. So Josh is going to create the MCP client. So usually our agent is an MCP client, and so we have to configure it, the transport that we want to use. Oh, and the default is still service and events. I think we'll be okay on that. So, and we could also put this configuration in a properties file instead of in code, just like we started with. There's multiple ways to provide configuration. This is an easy one. If you want to do it programmatically, we'll have to do
More
the
enlightened
properties
way.
based one because it's only one line of a property.
Okay.
Actually, we will in the workshop. In the workshop,
Yeah.
we'll do an MCP client with.
Okay.
Okay,
There's
so
that.
we've got our MCP sync client, and then instead of providing default tools, we set the default tool callbacks and provide that there.
Is that a builder now? Ooh. Okay. Okay. List.of. Oh, this does not make me feel good.
It's easier in properties. We'll have to.
Yeah, we'll figure it out.
We'll do the properties in the workshop.
Okay, var.
Okay, so you set up your callbacks,
Yeah.
and then we add them into our chat client. And now our agent should still know about our tools. It goes off through MCP, fetches the tool descriptions from the MCP server, puts those into the prompt that gets sent over to the LLM. And now everything should work just like it did before. Assume we don't need to clear any target directories or caching, but fingers crossed. No.
No. Did it
Denied.
client initialize?
Yeah.
How do we know if this got exported or not?
Do you have an MCP inspector?
We
Actually,
can run it. Well, here,
yeah.
let's just go back to the old thing, and we'll do the new thing in a second here. At tool param. Okay. Oh yeah. Method tool callback provider.
So there is a new way in Spring 1.1 that will just do all this for you. But we know that this way works, so we're going to go back to the Spring 1.0 kind of more manual configuration way, where we have to explicitly point it to the things that are going to be our tools.
Yep. But and the benefit of this approach is that you can take the code that we had for the local tool calling and just copy and paste it, and it's there. Okay, now take this, refresh, delete. Okay, so now, do you have any neurotic dogs?
Answer.
Okay,
Yay!
No.
It worked.
didn't.
Yeah. No, you can pick it up from. Oh, can't schedule an appointment.
Why?
Ah.
Sadness. What's the issue with this? Tool callbacks, scheduled MCP, is that the right host and port? Host and port.
Do you have to put? Does it automatically put the /SSE on that?
Yeah,
Yeah.
it's always
Okay.
done.
Huh.
Well, whatever.
Something new in 1.1.
We can figure
But
this out in the meantime.
You're going to see all this working, and you're in the workshop, and so we'll get it working. But actually, in the break, we're going to take a break and get some coffee, hopefully, or if there's
Java.
coffee out there, get some Java. And then when we come back, we are diving into hands-on. So
Yeah.
that's like your like run through of everything we're going to walk through for the first half of the workshop with Spring AI. We're going to do all that stuff and more, and then later today we'll get into agent orchestration with Babel. And there'll be
builds
plenty
on
of
top
time
of
for
Spring AI.
answering questions and diving in further. But anything else to add?
Okay.
Okay. And we're going to get this working in
10
the
minutes?
break. Let's do like 20 minutes. What
Yeah.
time is it? Is that Pacific time?
I sure hope so.
Okay.
Yeah, 11:08.
Okay. So let's resume in 20 minutes. So 11:30. We'll start diving into hands-on code.
Bye.
Okay. You want to get this working?
Yeah, let's go sit
Okay.
down.
Yeah.
I hate code that doesn't work perfectly the first time.
We did want to show you we actually got this
Point
thing
of order.
actually working. The problem was, like before, caching, something with the target directory. We had to just clean it, restart it, and we're going to investigate why something is different, because we've never needed to do those cleans before. But yeah, so this is, Josh is showing you. Oh, do we want to show the properties one?
Yeah, well, yes.
You got working?
Let me show you this
Oh, okay.
first. Here's the manual way, right? You create the client manually, and then you inject it thusly.
The default tool callbacks.
Tool callbacks, which is,
Yep.
whatever.
So that's wiring our agent side to the remote MCP server and
Yeah.
doing the configuration in code. And we can also, and this all worked. Do you want to show it working?
Yeah, I got rid of this. I'm using Spring AI 1.1 over here.
Latest, 3 days old.
Yeah, creaking the old ancient software from the distant past. Okay.
So
Oh,
we got
also,
our
it's holding on to the socket, so shut
graceful
down.
shutdown.
Immediate.
Great. Okay, so MCP server is running. Oh, and somebody, while you're doing that, somebody asked like what even is MCP? It just is a standard protocol developed by Anthropic that provides a way for a server to expose functionality to an LLM. And the functionality that it exposes can be one of like 6 different things. Tools is the primary one. So it's the ability for the LLM to know about and call tools.
Let me just,
Oh,
I just
it
did
worked.
fantastic. When can I pick up Prancer? November 20th at 7:34 a.m. Here's the adoption service. Here's the scheduler, the separate one with the I/O, right? So we've got 2 modules running side by side, and that actually has worked, despite the.
Great, so we got tool calling over MCP. So MCP, different pieces of functionality exposed to an LLM. Tools being the primary one, that's the one that we're showing here. There's also something called resources, which is like when you have an LLM that wants to read a file, that sort of thing. Images, those are MCP resources. There's prompts, which are essentially shortcuts that the MCP server provides to the agent side, which are like a shortcut to a larger prompt. And then there's a number of other pieces of MCP, which we won't go into today, or maybe we will later.
Yeah.
But yeah, so that's the primary purpose for MCP. Have a server that provides things to an LLM.
And there's a very convenient little utility you can use to inspect MCP services. Just do this.
Called the MCP inspector.
Yeah. Spin that up.
And that allows us to connect to an MCP server. In this case, we're connecting to our adoption MCP server. You can see the different pieces of functionality. Tools is the only thing that we did here. We get a schedule tool, and then the MCP inspector allows us to test, make calls to that, just like the LLM would in an agent. It was that we needed to clean our target directory, which is where the compiled files get stored. And we've never had to do that before, so we're not sure why we had to do that now. But something was being cached incorrectly in that target directory, and we'll investigate why that was. But once we cleaned it, restarted it, everything worked fine.
Yeah.
It just like wasn't seen that the tool is an option that it could call. So when we called the LLM, it's like, I don't know about any tools. And it's we would have to enable some debugging to discover that the tool list was not being correctly injected into the prompt.
Right. So now, once we did that, it rescanned the classes, and it found the new definition for the tool annotations. It's now in the tool. It's in the prompt, and everything worked as expected. Anyway,
Okay, it all works end to end. Let's
got
dive
20 minutes.
into the workshop. Well, we have all day to do the workshop,
I know,
but we
but
are
we
going to
gotta get them
stop.
started.
We are going to stop for lunch at noon. But I'm going to get you all started in the hands-on workshop, and yeah, let's do that. So for the hands-on workshop, it's all going to be. You're going to go through the workshop. All the content is online. I'll get you the information where to go and how to get everything set up here in a moment.
Kernel panic? Blue screen?
Nope, no blue screens. Josh thinks it's hilarious that I use Windows.
It actually is.
I mostly use Linux, but okay. Here is so what we're going to do. You all are free to work at your own pace. We'll help you with any problems. All of the content for the workshop is in this web page, which I'll show you in a minute. But this is the most important thing that you need to keep track of is that URL, because that is the URL to the workshop. So s12d.com/spring-ai-by-the-bay.
Spring AI by the Bay with dashes.
String AI by the Bay with dashes. So that's your workshop content. Everything that you will do through the rest of the day is going to be in there. And so I want to show you how that looks, what that looks like, and what we're going to be doing. And don't forget that URL, because
We provisioned like
I'll
200,
give it to
right?
you.
So I don't think we're gonna have
I'll
any
do it
issues.
again in a moment. But just to show you what's going to happen when you go to that URL. So I'm going to sign out here. s12d.com/spring-ai by the Bay. Okay, so when you first go there, you're going to get to this screen, which let me make that bigger. You can choose how you want to sign in. You do need to sign in to the workshop account, The easiest one is the email one-time password. That will email you a token to your email. You'll then be able to put in that token, and then you'll be asked to agree to the rules of using these workshop accounts on AWS. Essentially saying, like, don't mine Bitcoin. I get in trouble if you mine Bitcoin on this account. It says don't store personal information in that account. A few other things. So, yep, and I'll show you that URL again.
I got it.
Here, I'll pull that up for you. Okay, so once you get in, once you've done your verification of that, which I now probably need to do again because I logged out.
If I take a photo, you can copy it. No problem.
Okay, let me get my two-factor code.
It's really hard to see, isn't it? Oh. So small, right? Like I have a laptop that's almost as big as that. Oh, is it the glare? Oh, here, let me make it brighter.
There we go.
Sorry about that, man.
There it goes.
Cheers. Circulate if they ask. Anybody need that URL? I'm coming. How are ya? Good. S12D. Spring AI by the Bay. Oh, almost there.
Okay, so you'll see
Nice.
that
Well done.
after you get your
You okay?
two-factor code, then it's going to have me review that terms and conditions. I agree with them. I will join the event.
Spring AI by the Bay.
Once you have joined the event, you are going to be taken to a screen with an overview description.
Cheers, buddy.
But there's, at the bottom of this page,
Oh, good.
very important things, which you can always get back to if you need to. But this is going to be the VS Code instance that you're going to use for the workshop. So this is my values. You'll have your own. But I'm going to be able to launch that URL. I do need to get my IDE password and put that in. And then, I don't want to save it. This is my VS Code environment hooked to this workshop AWS account. This is where you'll be doing all of the inputting the code, running the terminal, all that kind of stuff is going to happen in there. So that's very important. That's on this homepage. You can always get back to it by clicking on
Send
this
yourself a
top
magic password
left
or log
button
in with
here.
your AWS ID. But send yourself a link. That's the
So
easiest one.
if you
Send
do
your
need to get
email
back to
one-time
your
password.
workshop login URL and login information, it's here once you're logged in. Yeah, question. Yes.
S12D.com
Yeah, I'll put that back up for a moment.
/ Spring AI by the Bay with dashes in between.
This one. Oh, and let's make that super big.
Yeah,
Yeah.
that is a very small screen. I cannot believe how teeny tiny that screen is. I was expecting there to at least be two of them, or maybe two of them back there, two in the front, but there's just one in the whole room, and it's just slightly smaller than my 16-inch laptop.
All right, let's make this bigger. Okay.
This is so cool. It's raining outside. You know, what else would you want to be doing today? I want to write code and hang out with cool people, and we're doing it.
We're doing it. Okay, here's your URL.
Nice. We have
Big
this
enough.
one.
It's as big as I can make it.
I think I walked around. I think most people are connected.
Okay,
They're-
you're getting
they're-
into the workshop. So all of the instructions for the whole rest of the day are in that workshop.
Yeah.
And you're free.
For the first, we have two workshops. For the whole rest of this first workshop.
Even the Embable stuff is
Okay.
also in there. But if you're super fast and get through everything that you want to get through, pause at the Embable one. Don't go on to Embable yet. At probably around, I don't know, 3 o'clock today is when we will go through the Embable one. And for that one, I'm going to walk through it with you so that I can explain all the agent orchestration, all the parts of Embable as we go through the Embable one. So we'll kind of do that one all together. But for the Spring AI one, you've already seen your intro to Spring AI.
Yep.
You've seen all the things that you're going to be going through. And so that one, free to go at your own pace through the Spring AI stuff. Just stop at the Embable part. Does that make sense?
That makes sense
Okay.
to me.
Yeah, cool. And then I'll be here if you run into problems, you have questions.
Me
We're
too.
here to help you. We will at noon go have lunch and then come back and continue. But we want to make sure that you have lots of time to get through the Spring AI stuff, get all that working, and then 3 o'clock we'll start the Embable part.
Is it really 3 o'clock? Wow, that's pretty. That's gonna. So how long does this thing go?
So we've got essentially 2 hours for the Spring AI workshop, and then we'll probably take a coffee break in the afternoon, and then come back for the Embable pieces.
It's gonna fly just like that. It's already been 2 hours since we started, and we haven't even. We just got started.
We're just getting in.
Yeah.
It's so people can usually get through the Spring AI workshop in about an hour, hour and a half. So I think we have plenty of time to get through that.
Yep.
Yeah. Okay, how's everybody doing? You got logged in to your AWS account. You got access to the VS Code environment. You see the instructions. You're able to start walking through, putting in some code.
Once you see the instructions, we can leave you alone. I just want to make sure everybody's there.
And if you run into things that don't work as expected, let me
James'
know,
fault.
because this workshop, I did test it on Spring AI 1.1, but there may be some nooks and crannies where I miss something. So
Imagine.
This is all hot off the press.
Oh. You and I were both in different cities last week, and now here we are.